Hello student, welcome back to my channel Kunal sir at JNET Chemistry Wall. Today I am going to discuss another very important topic which is from the real gas part and in the states of matter and gaseous state, which is nothing but a Vanderwaals gas equations. So what is first, let us know what is Vanderwaals gas equation. This Vanderwaals gas equation is nothing but for n mole of gases P plus n square A by V square into V minus NB equals to nRT. This is my actually one kind of real gas equations. So Vanderwaals gas equation is a real gas equation, and now our ideal gas equation was there. Ideal gas equation PV equals to nRT. This is the ideal gas equation. Everybody, I hope you know, P is the pressure of gases, V is the volume of gases, N is the number of mole, R is a universal gas constant, T is the temperature in Kelvin scale. But whenever we are talking about the Vanderwaals gas equations, which is one of the real gas equation, where with a pressure certain amount is added, whereas with the volume certain amount is subtracted, then only that will be equals to nRT. Now let me ask that first point, why we need to add that certain point with the pressure and why need to subtract certain thing from the volume, then only that will be equals to nRT. But whereas in an ideal gas PV equals to nRT. This term is called as a pressure correction. This is called as a pressure correction, whereas this term is called as a volume correction. Now why these things is needed for the real gas and nothing but in Vanderwaals gas equation, which the idea is actually in kinetic theory of gases, KTG. If you look at kinetic theory of gases, there we consider in kinetic theory postulate that there is no force of attraction and repulsion between the gas molecules, as well as the volume of the gas molecule is negligible with respect to the volume of the container, and the gas molecule are free to occupy the volume of the container. That's why volume of the gas is nothing but a volume of the container. But in reality, that situation are different. That's why all gases are real gas. Only at a certain pressure and temperature they behave ideally. Everybody we know boil temperature is that temperature where the real gas behave ideally. So not only that, the low pressure and the high temperature, the real gas behave ideally. Why? Because low pressure means volume will be high. Volume high means there is no question of a repulsive force. High temperature means kinetic energy high. Kinetic energy high means there is no question of a force of attraction. When there is no force of attraction, no force of repulsion, then the real gas behave the ideally. Now we need to look at why this pressure correction arises, that reason, why this volume correction arises, that reason. If you look at very carefully, whenever ideal gas they are telling there is no force of attraction and repulsion, but original picture is what? One molecule when going to collide with walls of the container, this is attracted by certain molecule towards the back. That's why what pressure they are exerting, that pressure will be less than that the real original pressure in ideal gas. That's why with the pressure we need to add certain things. What I am telling? I am telling like that whenever gas molecule is going to collide with the walls of the container, which gives rise to pressure of the gases, then immediately other molecule is attracted that molecule. That's why in reality what pressure is exerting, that pressure is less than the ideal gas pressure. That's why with pressure we need to add certain parameter, which is nothing but a n square A by V square. Now whereas the volume, regarding the volume what is happening? Whenever the molecule is colliding, we consider that two molecule is a hard sphere, then they cannot penetrate each other. Then if you consider that along this one, here the radius is this one R, here the radius is R. Now if you consider along this another radius, that means these two are radius, this is nothing but a incompressible volume. That means this molecule cannot compress the other one and occupy this volume. That's why this volume is considered as a what? incompressible volume, or this volume is nothing but it cannot be occupied by the gas molecules. So that's why the volume of the container is the volume of the gas is wrong. This much volume, that means what volume? Along to the 2r, according to that, if I consider one sphere, that volume is not able to occupy that molecule. So that is why that volume of the container is the volume of the gases is wrong. So that's why from the volume we need to subtract that some amount which is nothing but a NB, which is called as a incompressible volume. This is also called as a incompressible volume. Incompressible volume. Incompressible volume. So that because the molecule considered as a hard sphere, so that's why again I am telling this molecule cannot penetrate the other one, and this part of the volume cannot be occupied by this molecule, only it can up to come this level, this part it cannot be occupied. So that's why this volume is called as a incompressible volume. Now if you look at very carefully, where A and B is called as a Vanderwaals constant, A and B is called as a Vanderwaals gas constant. Vanderwaals gas constant, where A is represent the attractive force, A is represent the attractive force, A is represent the attractive force, where B is represent the repulsive force, where B is represent the repulsive force. If the size of molecule is more, if the size of molecule will be more, then my B will be more, then incompressible volume also will be more. Incompressible volume, that one also will be more. That's why based on the size that B also come into the picture. So now based on that we understood why pressure correction is needed, why volume correction is needed, and that parameter we understood. That means this part is represent is a attractive force part, this part is related to attractive force part, this part is related to repulsive force part, repulsive force part. Now you can find out the unit of A and B. What do you have to do? Suppose Na square A by V square is a pressure correction, then pressure unit is a ATM, then ATM equals to you put Na square A by V square. N is a number of moles, mole square, then V means volume, liter square, you can get the unit of A. Same way you can get the unit of B. How? Then NB is a volume correction, volume is a liter, then liter will be equals to NB. N is a number of moles, you will get the unit of B. These are the way you can find out the unit of A and B. Now our perspective are different. What is our perspective? If you look at, we got it that P plus Na square A by V square into V minus NB equals to RT. V minus NB equals to RT for N mole of gases. For N mole of gases. Now what I am telling? I am telling for 1 mole of gases. For 1 mole of gases. For 1 mole of gases. 1 mole of gases, what will be my Vanderwaals equation? My Vanderwaals equation will be P plus A by V square. P plus A by V square, V minus B equals to, here nRT will be there, P plus A by V square into V minus B equals to RT. This will be for 1 mole. Here N equals to, here N mole of gases is there. Here N equals to how much? 1 mole. Now I am talking about, already if you look at the plot, already Z is a compressibility factor, which is nothing but a PV by RT. PV by RT plot, if you look at, for the ideal gas, Z equals to 1, into PV by RT, that means Z versus P or V plot. The nature of the plot, you know, PV equals to constant, that's why it parallel to X axis. So now for ideal gas, these will be the Z versus P plot will be like this. But in reality, there are no ideal gas. On a certain point, real gas behave ideally. So that's why hydrogen gas always like this, helium gas always like this. But for other gas, suppose oxygen, methane, they will be like this type of plot we will observe. That's why this part, this side we consider as a plus, this side we consider as a minus, this part is nothing but a 1. Now this part is nothing but a attractive force, and whereas positive domain is a repulsive force. Positive domain is a repulsive force. This force is there. Now if you look at very carefully, there are two types of graph is there. One is only has that repulsive force is there, there is no kind of attractive force. But another kind of gas is there, in a low pressure region attractive force, whereas high pressure region there will be repulsive force is dominant, and in a certain pressure temperature, this point, they behave like a what? Ideally. So they behave like a ideally. Now next my point, at high pressure, this is my for 1 mole of gases Vanderwaals gas equation. So then immediately if I say that at high pressure region, at high pressure and constant temperature, at high pressure and constant temperature, at high pressure and constant temperature, what will be our situation? High pressure means what force is dominant? This region, what force is dominant? Repulsive force is the dominant. Then I can neglect the attractive force. So now at high pressure and constant temperature, neglecting the attractive force, neglecting the attractive force, neglecting the attractive force, neglecting the attractive force. Then what we can write down the Vanderwaals gas equation for 1 mole. That means this part I will neglect. Then P into V minus B equals to RT. P into V minus B equals to RT. With this equation, we will carry forward our explanations. Look at very carefully. That means neglecting the attractive force for 1 mole of gases, my Vanderwaals equation equals to P into V minus B equals to RT. Now if you look at very carefully, then I am taking that one, P into V minus B equals to P into V minus B equals to RT. Then PV equals to, then what I can write down? PV minus PB equals to RT. PV minus PV equals to RT. Then what I can write down? PV equals to RT plus PV. Now divided by RT both the side, then what I will get? PV by RT equals to 1 plus PB by RT. Now you look at what I am telling over here. This PV by RT equals to Z, then Z equals to 1 plus P into B by RT. That means 1 plus something means already I can say that high pressure at constant temperature, Z is what? Greater than 1. That I got it. That is not my intention. My intention is to explain one another thing. How that advanced question they can ask like that, at a high pressure region, at a constant temperature, Z versus they are giving you like at a high pressure and constant temperature, dz by dp value, they are giving certain value, they will give this certain value. Maybe they are giving 10.23233 like that certain value they are providing you. Now next what they are giving you. Now if you look at dz by dp at a high pressure at a constant temperature, they are putting that one. Then they are asking you what is your B. That is the question. What is your B? Now if you look at very carefully, then Z versus P plot from this equation, we can at high pressure constant temperature, Z equals to 1 plus P into B by RT. That means this is your Y, this is your Y, this is your C, this B by RT part equals to M, and this is your X. Y is equal to mx plus c, straight line equation, y intercept is positive and the slope is a positive, then your nature of plot will be what? Like this. This is your intercept, and these will be, if it is theta, tan theta will be equals to slope, but already they are telling dz by dp, dy by dx also slope, y2 minus y1 by x2 minus x1, dy by dx, that means dz by dp is a slope, they are giving certain value, maybe 10.233. Then slope is nothing but from here I can see B by RT is a slope M. So then immediately what I will equate, 10.233 will be equals to B by RT. Now from there I will get the B value, and B value once you get, they will ask you volume of one molecule. That is the question they ultimately will ask. What they will ask, that they will give you this data, they will tell you at high pressure at constant temperature dz by dp is 10.233. They'll ask you what is the volume of one molecule. Then from there I understood this is my z versus p plot, and from there I understood my slope is nothing but a b by rt, because y is equal to mx plus c, x is a p, y is z, 1 is c, this is c is a intercept which is 1, then b by rt is a m which is a slope and positive slope, that's why the plot will be like this, and y intercept also positive. Now from there I understood, okay, 10.233 equals to b by rt. Temperature they will mention, then you will get r value, you will put in joules, whatever unit they are giving. If it is there in calorie, you can take r value is calorie, or if SI unit is there, then you can put in joules, then you will get the b value. Now once you will get the b value, then the process is there to calculate the volume of one molecule. How you look at? I saw you, we took it the excluded volume like this picture. We initially consider the collision between the two molecules. They are hard sphere, they cannot penetrate to each other. The volume of one radius of one molecule is r, and now I told you this is the region which is a incompressible volume. This is the region which is a incompressible, and which is the nothing but a excluded volume, we can say rather. This is the excluded volume. What is the excluded volume? And per pair we are considering. Then excluded volume is nothing but a excluded volume. Nothing but I am talking about volume is nothing but a b, which is nothing but a 4/3. They are considered as a sphere. That's why 4/3 pi r cube. Now that sphere radius is r plus r, which is a 2r. 4/3 pi 2r whole cube, which is nothing but a coming 8 into 4/3 pi r cube. 4/3 pi r cube means volume of one molecule. Now as a pair, two molecule is there, we need to calculate b per molecule. That's why I need to divide it by 2. That's why 1 by 2 into 8 into 4/3 pi r cube. Now immediately you look at, then we are getting 4 into 4/3 pi r cube means volume of one molecule, because radius of one molecule is r and that molecule considered as a spherical. So that's why 4 into volume of one molecule, one molecule. Then we got it. Then per mole means what I have to do? Per mole means if I calculate b per mole means 4 into volume of one molecule, into Avogadro number, that is nothing but your b per molecule per mole. And now you look at, previously we calculate that they are telling slope dz by dp, which was my situation, which was at high pressure constant temperature. We got b by rt, which is nothing but a 10.33 some value they giving. Now you put r value, now you put temperature, you got b equals to 10.33. then once you get the b equals to per mole, per molecule will be how much? 4 into volume of one molecule into Avogadro number. From there you will equate that b will be equals to 4 into volume of one molecule into Avogadro number. From there you will get the volume of one molecule. Is it clear? I hope I able to give you enough clarity like this very nice concept about the how to calculate, if this type of questions they are giving, how to calculate the volume of one molecule from that type of condition, high pressure at a constant temperature. I hope I able to give you clarity each and everybody. To get this type of more and more clarity, please subscribe my channel, comment it, whatever your requirement you comment it. I will come to that concept in the next video, so that the entire student community get benefited by the Kunal sir's teaching and the video. Thank you very much. Thank you all, my dear student. See you in the next video.